Okay, guys, we're looking at derivatives of exponential functions. It's just hopefully just a short video to introduce it. So we're looking at exponential functions which can be categorized by y equals e to the x. There are obviously other exponential functions like y equals, for instance, y equals 2 to the x, y equals 3 to the x. They're exponentials. But when we're finding derivatives, y equals e to the x is the one we're going to be using. Okay. So when we have the function y equals e to the x, we find that the derivative is just itself, and that was part of the investigation that you did earlier in week 3. Okay, so when you have y equals e to the x, the derivative is the same, y equals e to the x. And then when you have y equals e to some function of x, which is like an extended function, what we're going to do is we'll just write this down to start with, and I'll show you how it works. The derivative is the derivative of the function goes out the front, and then you just leave e to the function. Okay, so when we look at some examples, hopefully that'll make sense. But what we're going to do is explain the second one before we move on. Okay, so for the second part, y equals e to the fx. So what we do is we set up a substitution so that we change, rather than having a complicated one, we just have y equals e to the u. And then just note, we're going to be using the chain rule. So when when u equals fx, du dx is just going to be f dash x. Now, from that first one, the first slide, when you have just a simple function, the derivative equals itself, but now we're deriving with respect to u, not with respect to x. So the chain rule that we've already done this year, dy dx equals dy du times du dx. Okay, just remember that the du sort of cancel out, so you've still got your dy dx. Now, the dy du is that part, so that's going to come as the first part, and then du dx, sorry, I beg your pardon, du dx is the second part, and dy du is the first part, beg your pardon, so that's going to come across here. And then e to the u is just e fx, okay, e to the u, so straightforward. And so we end up with the shortcut being, when you have a function for the exponential, we just multiply by the derivative out the front, and then just leave the exponential. Okay, so copy that down if you want. It's not important that you know the proof. Okay, so let's have a look at some examples. Okay, so this is a function. So the derivative will be the derivative of 2x which equals 2, and then just write the e as it is. Okay, and that's the end of it. Next one, the derivative of that function is 4, and so when we multiply 4 by minus 5, we get minus 20, and then just leave the e as it is. Okay, copy that down and come across. Okay, so we're now looking at some extension questions. Okay, find the value of the gradient at x equals 1 for the function. Okay, so the gradient is the value of the derivative at a particular value. Okay, so y dash, okay, multiply, the derivative is going to be 3, so we get 3e to the 3x, and so at x equals 1, y dash equals 3e to the 3 times 1, and that's going to be the gradient. Okay, now this is a number, because e's just a number, and then e cubed is another number, so it's a value. It's going to be a messy decimal, but that's what the value is. Okay, copy that and come across. Okay, find the equation of the tangent to y equals e x squared at x equals 2. Okay, so we need like a y equals mx plus b answer at the end, and the m is going to come from the derivative. Okay, so first thing we do is y dash. Now that derivative will be 2x, and then we just write e to the x squared, and then at x equals 2, that value there, y dash equals 2 times 2 times e to the 2 squared, so we end up with e to the 4, so it ends up being 4e4, which is a value. Okay, change its color. At x equals 2, y equals e to the 2 squared, which is e to the 4. And then I'm going to put y equals mx plus b. So e to the 4, that value equals 4e4 times the x value, which is 2, plus b. That's what we're just got to find the value of b, and then we finish the question. So e to the 4 equals 8e to the 4 plus b. So b equals minus 7e to the 4. That value just comes back by subtracting. And so your final answer is y equals m, which is 4e, 4x minus 7e4. And that's your y equals mx plus b. And if you wanted to, you could factorize it just to make it a little bit different. So e to the 4 is common, 4x minus 7. Okay, and that's useful if you're trying to find the how to sketch it, how to find the x-intercepts or the y-intercepts of the gradients. And I think that's the last slide. Okay, so have a copy of that. There'll be some exercises to do from the textbook. I'll write them up in class. Thanks. Bye.